Good day, grade 10 learners. Welcome to our mathematics lesson. I am Skulile Ngube, and this lesson is probably brought to you by the Gauteng Department of Education. We are revising the tangent graph in this lesson. Let's be ready for our lesson, grade 10, and make sure you have your pen, your pencil, your calculator, and your ruler. We're going to need those things as we revise the tangent graph. Do you remember the tangent graph? Under trigonometry or trigonometric functions. Okay, right, let's do it. Right, at the end of lesson, you should be able to sketch the tangent graph. I'm going to remind you how to sketch the tangent graph. And then we're going to revise the effect of A and Q on the tangent graph. And we're going to look at examination type questions involving the tangent graph. Okay, that's what we're going to do in this lesson. Right, we have done trigonometric ratios. Remember, sine of angle theta, if the angle is theta, sine of angle, if the angle is x, cosine of angle, tangent of angle, and then also we did trigonometric equations, and then we have done trigonometric functions. Okay, right. And then this is our baseline activity. I want us to draw the graph of f of x is equal to tan x. I don't want you to use a calculator here. I want you to remember the critical points. We talked about this in our lesson. Critical points. When you come to the tangent graph, what are the critical points? You must know those points. Okay? But I'm going to give you 2 minutes to draw the Cartesian plane, and then after 2 minutes, I'm going to give you 5 minutes to draw what? To draw the graph. Now, let's just draw the Cartesian plane. Everyone, let's draw our Cartesian plane. Once I'm done with mine this side, you must also be done with yours. Okay? Right. Now, this is our Cartesian plane. Draw on your graph. It must be big. Don't draw a small thing. Maybe half of a page or a quarter of a page. Okay? Right. This is the y-axis. You must have your y-axis there. And then draw your x-axis. It must be similar to this one, the blue one. Here, I'm just showing you. You don't need to draw the grid. Okay, you don't need to draw the grid. So 0, and then let's have 2, 4, 6. We need this Cartesian plane because we're going to draw the other graphs on it. So let's make sure we have something similar to this. -2, -4, -6. Please, let's have that. Okay. Right, and then we have our 45 degrees. We have our 90 degrees, 135 degrees, 180 degrees, 225 degrees, 270 degrees, 315 degrees, and then 360 degrees. That's our domain up from 0 to 360. That's our x. Then that's our y. Okay? Right. Everyone should be having the Cartesian plane now. Let me give you 5 minutes. 5 minutes to sketch the graph of f of x is equal to tan x. Let's have our 5 minutes. Welcome back, great friends. Let's mark our work. Right, what did we say in the previous lesson? Or from what you've learned? The tangent graph, we have to remember the critical points every 45 degrees, okay? At 0, where is the graph? At 45 degrees, where is the graph? At 90 degrees, where is the graph? Like that, every 45 degrees, up to 360. In this domain, 0 to 360, you must know that there are two asymptotes. Where are those asymptotes? At 90 degrees and at 270 degrees. Start by drawing those asymptotes. Okay? So we have the two asymptotes. You have to remember that. And then at 0, the graph is at 0. So it means the y value is at 0. And then at 45, you must know that the y value is 1. Okay? Right. And then you can sketch your graph like that. And then at 135, where is the graph? Or what is the y value? It is -1. And then at 180, that's an x-intercept. I forgot that one. 0 here is the y-intercept and also the x-intercept. You must also know where the x-intercepts are. So 180 is the x-intercept, the second one from the origin. And then 225 is 1, y value is 1. So once you remember these critical values, it becomes very easy to draw the tangent graph. And then 270 is the asymptote. At 315, that's -1. -1. And then 360 is another x-intercept. Okay? And then you can sketch your graph like that. Done. Right, I want you to correct this graph if you got it wrong. Let me see. Okay, let me go back. Right, I want you to correct this graph if you got it wrong, because we are going to draw two more graphs on the same set of axes. So I'm going to give you 2 minutes for corrections, and then after those 2 minutes, we will continue. Correct your graph, make sure that it's neat and it's big enough, and then after 2 minutes, we're going to continue with our lesson. 2 minutes. Right, welcome back. Let's do the rest of the lesson. For the graph of f of x is equal to tan theta, and then for this domain, we have these points. We have discussed these points. Let's just talk about them. We said 45, 1, 135, -1. These are the critical points that we're talking about. And then on top of these, we talked about the asymptotes. Please remember those. And then these points are useful when sketching the tangent graphs. These points are very, very useful when you're sketching the tangent graphs involving the vertical stretches, okay, and then also the reflections about the x and the y-axis, and also the vertical shifts. We'll see how these points shift or how these points are transformed because of these vertical stretches and reflections, right? And then we'll sketch the graph of, we already have f of x is equal to tan theta. That's the graph that we drew in our baseline activity. Right, on the same set of axes, we're going to sketch the graph of g of x, and also we're going to sketch the graph of h of x. Right, so, and then label the graph clearly. Let's just do that. Let's start with the graph of g of x. I would prefer you not using the calculator or even the table of values here. I want you to just use the effect of Q. The red graph is our graph for f of x is equal to tan x, or tan theta. We're using theta, so let's use theta here. So this is the red graph. So what happens to the red graph, f of x, to form g of x, which is tan theta plus 1? On the same set of x's we drew our first graph, can you draw the graph of g of x? I'm going to give you 2 minutes. Right, welcome back, returns. So now plus 1. When Q is positive 1 means every point is shifted upwards by 1 unit. So this point 0, 0 is shifted upwards by 1 unit, is going to be there. Then 45, 1 is going to be shifted by 1 unit, goes up to become 45, 2. 45 degrees 2 there. You see that? So shifted upwards by 1 unit. And then even this one here, 135 and negative 1 shifted upwards by 1 unit. In 180 here and 0 shifted up by 1 unit. 225 and 1 shifted up by 1 unit, now 225 and 2. See, like that? Okay. And then we have this point shifted up by 1 unit. And then we have this point shifted up by 1 unit. We have the graph. So this is the graph of g of x. Okay, right. Now we want to draw h of x. We want to draw h of x. Remember, we're revising, trying to remember what we learned about the effect of Q and the effect of A. Right. Now, what about h of x? H of x, where is it? H of x is equal to tan theta minus 1. that without using the table of values, without using a calculator, just the translation, so translation, what would be the graph, or sketch the graph of h of x. Let's try to do this in 2 minutes. Right, welcome back, grade 10. Right now, tan theta minus 1. So what happens here? The graph shifts downwards by 1 unit. So every point will shift downward by 1 unit. So like this, and then this point will shift downwards by 1 unit. Going to be like this, and then this point also will shift downwards by 1 unit. The asymptotes do not change. Do you see that? It's just vertical shift, upwards, downwards. Okay, right, this is the graph of h of x. This is the graph of h of x. Right, now let's continue now. We have seen the effect of q. We've managed to sketch the graph of tan theta, the tangent graph. Also, we've managed to revise also the effect of q. Now, we have seen that f of x shifts upwards by 1 unit to form g of x, and also we've seen that f of x shifts by downwards by 1 unit to form h of x. Right, let's discuss some of the things, key features for these graphs. The range. What is the range of these three graphs? It's just the same, okay? And then what is it? 1 minute. What is the range for these three graphs? Right, welcome back. The range, these are the y values. The y values. You can even see this graph. We have arrows here to show that this graph continues, goes down to negative infinity. Even here goes up to positive infinity. So the range, we're saying y is element of real numbers, or you can say y is from negative infinity to infinity. Okay, right. That's what it means then. How can you write it? Can you write it like this? Y, is it an interval? No, it's fine. Y is from negative infinity to infinity. So these formats are okay. Okay, these formats are okay. Right, maximum and minimum values. Do we have any maximum or minimum values? Do you remember when I talk about the cosine graph? The cosine graph will be going like this. And then when it comes here, it turns like this. Or the sine graph. Those have the minimum values. They have the maximum values. But the tangent graph, does the tangent graph have maximum value or minimum value? No. Okay. The graph defined by this has no minimum or maximum value. It goes to positive infinity, it goes to negative infinity. Okay. Right, the period, I want to give you time for this, maybe 1 minute. What is the period of the tangent graph? Of this graph in the form, we're looking at the graph of the form f of x is equal to a tan theta. Just that. What is the period for this graph? 1 minute. Right, welcome back. Now, for the three graphs, period is 180 degrees. Remember that the period for the tangent graph is 180 degrees, meaning that the graph repeats itself after 180 degrees. Like here, from negative, not from negative, from 90 degrees to 270 degrees, that is 180 degrees. So the graph will keep on repeating itself after every 180 degrees. That's the period there. Right, we have the graph of f of x. Now don't think of the f of x equal to tan theta now. It's different. F of x is 2 tan theta. Our a is now 2. And then g of x is negative 2 tan theta plus 1. They are drawn on the same set of x. I'm going to show you. You don't need to sketch this. I have them, so I'll just show you. Right, these are the two graphs we're going to discuss. We want to see the effect of a. Remember, we're saying f of x is equal to a tan theta. What is the effect of a on the tangent graph? Right, so we have these two graphs. F of x is equal to 2 tan theta. The red graph is for this equation. Right, do you remember our original graph, which was tan theta, not 2 tan theta? Where was the graph at 45 degrees? It was at 1. Let me try to choose another color here. Right, it was at 1. Okay, and then the graph was going like this. Now, what has happened to this point? Now, this one was 45 degrees 1. Now it is 45 degrees 2. Do you see that? It's taking the value of this a. The y value is taking the value of this a. Okay? And then here it was 135 going with negative 1. And then 225 was going with 1. And then the graph was something like this. Well, not touching the asymptote there. Right. And then it was 135 negative 1. Now it's 135 negative 2. Do you see the effect of 2 there? Okay, so all the points are like that. So the x-coordinate of the points, the x-coordinates of the points are not changed. They're still the same, but the y coordinates are changed by A. So the graph becomes vertically stretched because of that. The graph becomes vertically stretched because of this A, right? And then let's discuss g of x now. G of x, if you check, the blue graph represents g of x. This is the equation of f of x. This is the equation of g of x. I want us to compare these two graphs. Right? F of x and g of x. I'll give you time to discuss this. What has happened to f of x to form g of x? What has happened to f of x to form g of x? Explain the transformation of f of x to form g of x. Let me give you 2 minutes so that you can discuss this with your colleague. 2 minutes, and then after 2 minutes, we're going to come back and discuss this together. 2 minutes. Right, welcome back, Cretans. Remember WhatsApp line, Cretans. Let's discuss during our lesson. 063-508-1301. Let's discuss during our lesson, okay? Right, what did you find out? What did you find out? Now, if you check f of x, I'm not sure if this is clear. Let me change the color. Let me change the color here and try to, or if I use blue, then it's going to confuse us. Let me change to choose green. Right, you check, I have lines here. You see these lines? They're faint. Let's ignore the blue graph first. Let's just ignore the blue graph. Look at the red graph and the green lines that I've drawn, or the green graph that I've drawn here. What has happened to the red graph to give us the green graph? What has happened to the red graph to give us the green graph? Do you see that the red graph is sort of reflected about the x-axis? It's a reflection. This point, this part goes above and becomes this part. And then this part goes down and it becomes this part here. This is a reflection about the x-axis. Okay, which is the effect of this, the change in the value of 2 here, from being positive 2 to negative 2. So when the a value changes sign, it means reflection about the x-axis. When the a value changes sign, it means reflection about the x-axis. And then after being reflected, about the x-axis, then what happens thereafter? It is reflected about the x-axis, then shifted upwards by 1 unit. Where do we see that? We see it here. Let me go back to my red color. We see +1. Okay, -2 here, it means the graph is reflected about the x-axis and then thereafter shifted upwards by 1 unit. That's how f of x is transformed. Remember transformation. You're doing transformation in grade 9. The reflections, the translations. This is what is happening here. Reflection about the x-axis, then translation shifted upwards. Okay, that's what happens there. So the graph of f is reflected about the x-axis and then shifted upwards by 1 unit to form the graph of g. Okay, right. Now let's check the next part of our lesson. What is the effect of q? I think this is repetition. Effect of q is for the vertical shift to be To be specific, the graph is actually shifted by 1 unit upwards because our q is +1 in this case. But just to generalize, positive q means the graph is shifted by q units upwards. Negative q, it means the graph is shifted downwards by q units. Okay? Right. The effect of A, we have seen the effect of A. A stretches the graphs vertically. If A becomes bigger, the graph is stretched vertically. What else? If A changes sign from being positive to negative, the graph is reflected about the x-axis. So A stretches the graph vertically, and then when A changes sign, the graph is reflected about the x-axis. Okay? Right. So we've revised this. We've revised how to sketch the graph, what is the effect of Q, what is the effect of A. What next? Okay, what we have, I just extracted some questions from the Siavula textbook from roughly page 112 to 245. I extracted a few questions there. So here I'll be giving you time. This is the part now of interpreting, just easy questions. I'll give you time to try with the questions, and then after that we discuss. Is that okay? Right, let's do that. Now the first question says, the graph alongside is for f of x is equal to a tan theta plus q for this domain. Point A is 0, 0. Then point B is 45 degrees 1, so it means point A is here. Determine the value of A and Q, and hence the equation of F. Let me give you 4 minutes for this. And then after 4 minutes, we will come back and discuss. Let's try for 4 minutes. But welcome back. Let's discuss this. Like I said, grade 10s, it is very important for us to understand the key points and the key features of our parent graphs. I'm talking about now the graph of y is equal to tan theta, y is equal to cos theta, y is equal to sin theta. We call those the parent graph. Some people say the mother graph, something like that. Okay, it is very important for us to understand those graphs. Like here, our parent graph is y is equal to tan theta or tan x. We're using x for our angle there. We must know the critical points and the critical what and the key features. Right, it becomes very easy for us to interpret any other graph that is due to the transformation of this. It becomes very easy. Like here, you can see that 45 degrees will give you 1. The asymptote is at 90. The x-intercept is at 0. So basically, this graph, nothing has happened to it. Nothing has happened to it. Because we know the critical points of this graph. It should be 0, 0, 45, 1, then 90 asymptote, then negative 135 and negative 1, and it is at negative 1, 135. 180, 0. So nothing has happened to the graph, to the parent graph. So it means our A, which is here, it is 1. And our Q here is 0. Okay? Right. And then what else can we do? We can use the given points. We can use the given points. Let's do that. Now we have our equation f of x is equal to a tan theta plus q. In this case, our theta is x. We're using x there. Right? And then let's substitute 0, 0. Y is 0, x theta is 0. So 0 is equal to a, then tan 0 degrees plus q. And then what is tan 0? Tan 0 is 0. You can put it in the calculator, you see that tan 0 is 0. So meaning that 0 is equal to 0 plus q, meaning that q is equal to 0. Just proved what he said when he started, right? Now q is equal to 0. Let's substitute this point now. And then now we know what q is. So it's going to be, where there's f of x, we put 1. Where there's theta, we put 45 degrees. So 1 is equal to a, then tan 45 degrees, and then plus q. Our q is 0. We just got our q. Okay? And then what is tan 45 degrees? Tan 45 degrees is 1. So it's got 1 is equal to a. A times 1 is a. Meaning that a is equal to 1. That's what we said here when we talked about this. That this graph, nothing has happened to it. So a is equal to 1. Therefore, the equation of f of x is equal to 1 tan theta plus 0. Q is 0. So we just remain with this. Done. Okay. And then the next graph now, you can try. I want you to try. Let me give you more time, maybe 5 minutes on the next graph. Okay. Let me give you 5 minutes. Same concept. Same concept. But now it's not going to be, we're not going to be having a is equal to 1 and q is equal to 0. It's going to be something else, isn't it? Right, let's try. 5 minutes. Well, welcome back, cretins. Welcome back. Now let's do this together. The graph alongside is for f of x is equal to a tan theta plus q for this domain. Right, point A means this point A here is 0 and then 1 over 3. 0, 1 over 3. And then point B is 45 degrees, 10 over 3. Right, what can you get from this? Right, determine the values of A and Q. Like I said, if we know the critical points for our parent graph, it becomes very easy to interpret the other graphs. You see here, so our value of y here for B is changed from 1 to 10 over 3. Okay, you will see how this is connected to the value of what? Of A. We'll see how it is connected to the value of A. I want us to use these points. We're going to substitute them, and then we'll see how it is connected to the value of A. Even this one here, you will see how it is connected to the value of Q. Okay, let's substitute. So we have f of x is equal to A tan theta plus Q. Let's substitute this point A, 0 and 1 over 3. So where there's y, we put 1 over 3. Where there's x, we put 0. It's going to be 1 over 3 is equal to A, then tan theta, tan 0, we put 0 there, and then plus Q. What did you say tan 0 is? Tan 0 is 0. So this whole thing becomes 0, meaning that 1 over 3 is equal to Q. Do you see this? The coordinates of A there, 0 and 1 over 3. And our Q value is 1 over 3. Meaning that our graph shifted upwards by 1/3. It shifted upwards by 1 over 3. Okay? And then let's use this other point. Now we have the value of Q. So where there's f of x, we put 10 over 3, and then where there's theta, we put 45 degrees. So it's going to be 10 over 3 is equal to, we want to find what? A, we don't know A, and then tan 45 degrees, and then plus what? Q. We now know our Q, which is 1 over 3. Then what is tan 45? Tan 45 is 1. So it becomes 10 over 3 is equal to A times 1, and then plus 1 over 3. Okay? Right? And then what do we do? What do we do? We can subtract 1 over 3 from both sides of the equation. Becomes 10 over 3 minus 1 over 3 is 9 over 3, which is 3. 3 is equal to A. Right? Do you see that? So now it means the graph is shifted upwards by what? By 1 over 3 units. Okay? Right, by 1 over 3 units. Let's say from 1, the parent graph will be at 1. If we say 1 plus 1 over 3, what do you get? 1 plus 1 over 3. The graph is shifted by 1 over 3 units. It's like what? And then this is like oh, it's not coming out here. This is 1 over 3, and then oh, what is our A? Oh, A is 3. Okay, A is 3 is fine. Let's leave it. A is 3. So it means our graph is going to be, now confusing me, it's fine. Let's just put the value of A and value of A and value of Q. So it means f of x is equal to 3 tan theta, then plus 1 over 3. Okay. I'm not sure what I wanted to investigate there, but it's fine. So now we have the value of A, we have the value of Q. That's the equation there. Okay? Right. Now let's try the next one. Same concept now. Same concept. Let me give you just 2 minutes. 2 minutes, then we conclude, and then I'll give you homework, then we finalize our lesson. 2 minutes for this one. Right, welcome back. Pretend, let's do this together. It's very safe to use calculations, that's what I discovered. So let's just stick to the calculations and then get our values for A and Q. Right, so we have our point A, which is 0, -3. And then we have our point B, which is 45 degrees, -2. Right, 0, -3. Right. Then let's substitute. Let's start by substituting this point. Where is y, we put -3. Where is x, we put 0. So it becomes, we're using this equation, okay? So 0 is equal to, where is y, put -3. So -3 is equal to a tan. It's basically the same thing. 0 degrees, then plus q. Okay, and then this whole thing is going to be 0, so we remain with q is equal to -3. See that the graph is shifted downwards by 3 units, shifted downwards by 3 units. Let's find the value of a. We're going to substitute this point, so it's going to be -2 is equal to a tan 45 degrees, and then plus q. Our q is -3. Okay, this is 1a, because tan 45 is 1. It's going to be -2 is equal to a minus 3. And then add 3 on both sides of the equation, you get that a is equal to 1. Okay, a is equal to 1. Therefore, the equation of this graph is f of x is equal to tan theta, because there's an invisible one here, and then minus 3. That's it. Done. That's how you can find the equation of the graph using the given points. Okay, right. I want us to take a short break, and then after the break, well, I'm going to give you homework. Let's take a short break.
The road to success is to commit to yourself. In order for you to become who you want to become as a student, you need to commit to reading your books, to studying, to bettering yourself. I know it's not going to be easy. Actually, no one said it's going to be easy. But if you put in the work, the results will show in your life. Tap into your power. Sometimes you will feel like putting away your books, and not reading as much as you're supposed to be. But I want you to commit, because through commitment, there is infinite power.
Welcome back, Cretans. Now this is your homework. Let me give you 1 minute to copy your homework, and then after that we summarize our lesson. 1 minute. Right, welcome back. This is your homework. Now, let's go to the summary. The range of y is equal to 8 and x. We talked about the range. Y is from -infinity to infinity. The period is 180 degrees. And then the graph of y is equal to 8 tan x plus q, cast the y-axis at 0q. Okay, right, if q, let's say, is 2 here, the y-intercept is going to be at 0 degrees and 2. Right, the point 45 degrees and a plus q lies on the graph of y is equal to a plus tan x plus q. Okay, you can generalize it like this. Please write it down, you can use it later. right? And then the graph has no maximum value, no minimum value. And then for the theta, the domain from 0 degrees to 360 degrees, the asymptotes are at 90 degrees and 270 degrees. Remember these things, great turns, right? Okay, right, we have done the revision of the tangent graph. In our next lesson, next week, don't miss the lesson, we are going to revise the midpoint theorem. Do you remember the midpoint theorem under Euclidean geometry? It's another very crucial concept. Don't miss the lesson. We're going to be revising it next week on Thursday, 9 a.m. Thank you very much. Goodbye.